20-1s. The end is near for Chapter 6, Rational Expressions and Equations. I know this is a lot of fun, this unit, with all the factoring and all the fraction work, but our assessment's coming up. So, short video, a little bit of an overview of everything that we've done. I'm not going to spend a ton of time going over the examples, but a quick refresher. Here's the things you got to know how to do. Here's the things you need to review to make sure you know how to do. So, away we go. First thing is you need to be able to factor. This whole unit is about factoring. We did a big factor review last unit when the factoring came into it. Because every question, simplifying rational expressions, multiplying or dividing rational expressions, adding or subtracting rational expressions, solving equations of rational expressions, they all require you to factor. You need to be able to make sure you understand that GCF factoring always happens first. Always look for GCF to start. Then you look for that basic trinomial to possibly factor. You look at the complex trinomial that requires the decomp factoring potentially, and you have the difference of squares factoring. You need to be familiar with all of those and competent at them. Because we also then have to worry about non-permissible values. Now this is sort of a little piece that's important in this unit, but separate from all of the work. Non-permissible values, or NPVs, are the values that make a rational expression or equation undefined, because everything is fractions in this particular unit. So as soon as you have all these fractions, whether you are adding or subtracting the fractions or whatever, or an equation with the fractions, we cannot have a zero value in the denominator. If I have a value of 0 in any denominator, it's just not allowed in math. It's undefined. So an NPV is any value that makes a denominator a 0. And we'll be looking at that throughout this review. So what we do have, though, to start with, first process we talked about was simplifying a rational. No calculations, just like with a fraction. If you have 5/10, well, we can simplify it to 1/2. In order to simplify, factor the numerator and denominator, and then cancel the common factors. Remember, please, that a binomial factor must be canceled in its entirety. So I have an x factor, I have an x plus 6 factor, and I have an x minus 5 factor. I must cancel the x plus 6 with an x plus 6. I have to cancel the x minus 5 with an x minus 5. So in this case, there would be no simplifying. I can't cancel anything. You are not allowed, oh, here's an x and here's an x. Cancel those. No, because this x minus 5 is the factor all by itself, the entire thing. So I would have to cancel x minus 5 with an x minus 5. In this case, that particular rational expression can't be simplified. But here's one that can. I suggest stop the video, give it a try, see what you end up with. So here we go. I am going to factor. Up top, first thing I can do, factor out a common factor of 2. So we end up with 2 brackets, x squared minus 2x minus 35. Well, I still have a simple trinomial that can be factored. Multiply to negative 35, add to negative 2. We've done this to death. This is what you should be able to come up with without too much difficulty. So we end up with 2 times x minus 7 times x plus 5 in our numerator. Our denominator, 3x squared minus 147. It's not a trinomial, but there is a GCF. So I'm going to factor out a 3. So we're left with 3 times x squared minus 49, because I divided both of those terms by 3. But now I'm hoping you recognize that you have a difference of squares. So this can be factored one step further. 3 times x minus 7 times x plus 7. So there's the factored form. Now that I have all of the parts, now I look to see what can be canceled. In this particular one, x minus 7s will be canceled. I still have an x plus 5 and an x plus 7 that can't be canceled. Now I do have two coefficients, two constants out front, 2 and 3, but since they don't have a common factor, they can't be reduced. This particular initial rational can be simplified down to 2 times x plus 5 over 3 times x plus 7. There's the simplified form. Factor and cancel. The next thing we did was we multiplied and divided rationals. Now these next two processes are expressions because we don't have an equal sign. So we want to multiply and divide two things. First thing, factor numerators and denominators. Second thing, before any canceling gets done, if necessary, convert your division to multiplication or keep the multiplication. Once everything is multiplication and there is no division, well, rules of fractions allow us, because it's multiplication, to cancel the common factors. Remember, canceling occurs one numerator, one denominator with a common factor in it, and we cancel those. So there's the processes we want. Factor numerators and denominators. Make sure division is multiplication. Once it's multiplication, cancel like crazy. Here you go. X cubed minus 4x divided by 5x plus 15 divided by x minus 2 over 20x plus 60. So I suggest stop, give it a try, see what you come up with, and then we'll do it together. All right, so hopefully you came up with the right stuff. Here's what I would look at doing. This first numerator, we have a common factor of x, left with x times x squared minus 4 after I factor out an x. I still have a difference of squares. So x squared minus 4 can be broken into x plus 2 times x minus 2. So there's the first x times x plus 2 times x minus 2. Second part of that, the denominator, the second part of that first rational, we have a common factor of 5 that can be factored out. So we're left with 5 bracket x plus 3. That's being divided by the second rational, which is x minus 2. And we have a 20x plus 60. Well, that has a common factor of 20 that can be factored out, which leaves us with 20 times x plus 3. Now, here's where NPVs come into play. Because in NPV, the non-permissible values, any point in a question where a denominator becomes 0 is a bad thing. So this denominator here could become a 0 if this x plus 3 were 0, because you would have 5 times 0, which is 0. So what would make the x plus 3 0? Well, that would be if x was negative 3. So x equal to negative 3 is a non-permissible value. We don't want x to equal negative 3. When I look at the second rational, it's the same thing. I don't want this rational to be 0, which could occur if I had 20 times 0. That 0 would occur if x plus 3 equaled 0, and that would happen if x was negative 3. So right now, negative 3 is our non-permissible value for this situation. But we can't have a denominator of 0 ever. So the second thing we talked about, we have x plus 2 times x minus 2 over 5 bracket x plus 3. Divide is going to become multiply, and we always then reciprocate our second fraction. The divisor has to be reciprocated. Now at this point, stop again, now we have a new denominator here. So I wouldn't want this to be a denominator of 0 either, because if a 0 happens anywhere, it's a problem. When would x minus 2 equal 0? Well, that would happen if x was 2. So 2 is another non-permissible value for this particular question. But now that I have multiplying rationals, sorry, it should be equal to the above process. Multiplying rationals requires us. It doesn't require us to, but it's very helpful when you're multiplying rationals or fractions, you can cancel before multiplying. So where do we have factors are the same? Well, we have an x minus 2 in the denominator and an x minus 2. Because we're multiplying one numerator, one denominator from the question at a time. What else do we have? We have an x plus 3 and we have an x plus 3. Now we also have this 5 and the 20. 5 and 20 are monomials. We can cancel part of it. What could I reduce 5 and 20 by? Reduce it by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. There we go. We've canceled everything we could. So to multiply, I multiply my numerators. All I'm left with is an x times x plus 2 times the 4. Well, in 4 times x leaves me with a 4x times x plus 2 for my numerator. My denominator, everything canceled except 1. And the denominator of 1 does what? It does nothing. So I don't even need the denominator of 1. So this expression, this division question, becomes this quotient as long as we don't have x equal to negative 3 or 2. So those two go together. There's multiplying and dividing. Adding and subtracting rationals. This is the one that requires a lot of steps. Because just like adding and subtracting fractions, we need the common denominator. And when we have a common denominator, we need to make sure the fractions stay equivalent. So we have to start to multiply numerators by those missing common denominator parts, because we're going to put the common denominator in. But if I'm going to change a fraction's denominator, I need to change its numerator. And the last step for adding and subtracting fractions is to work with the numerator. So we're going to have to expand and simplify the numerator, which is where the add subtract step really comes in. So here we go. 5 over x plus 7 plus 2x over x minus 4. Well, common denominator. Here we have a denominator of x plus 7. Here we have a denominator of x minus 4. I need both of those parts to be in the denominator. X plus 7 and x minus 4 need to be in the denominator. So what we have to do is we hopefully see that this first rational is missing the x minus 4 part in its denominator. So I need to multiply the denominator by x minus 4 to put it in as the common denominator. But if I'm going to change my denominator, whatever I do to the bottom, I have to do to the top with fractions to maintain equivalence. So I'm left with 5 times x minus 4 as my first numerator calculation. Now the second rational here had the x minus 4 in the denominator. It was missing the x plus 7. So we need to multiply the denominator by x plus 7 to put it into the denominator. But if I'm going to change the denominator by x plus 7, I need to change the numerator by x plus 7. So what do I have there? There's my second numerator part. They're being added, so I want to add 2x times x plus 7. And it's all over the denominator of x plus 7, x minus 4. Figured out my common denominator, added those parts to the other denominators, but maintained equivalence by multiplying my numerators by what was changed in the denominators. So now I have to finish my numerator work. I need to expand, and in this case, it's nice. It's just distribution. I have no FOIL happening. We end up with 5x minus 20 plus 2x squared plus 14x. And all of that is over my denominator of x plus 7, x minus 4. Finish my simplifying. Combine my like terms here, which are my x's. I have 2x squared plus 19x minus 20 all over x plus 7 times x minus 4. So there, we found the common denominator, kept our rationals equivalent, worked with the numerators. The last step is you always have to look to see if you can simplify your final value. Well, I would only be able to simplify if I could factor this top part. So this numerator, can it be factored? Well, complex, 2 times negative 20. We need to multiply to get negative 40, but add to get 19 if I'm going to do decomp. Can I multiply 2 things to get negative 40, but add to get 19? That's the question. So when I think of that, there is not anything that will multiply to negative 40 but add to 19. It can't be factored. So this is our answer because that can't be simplified. But what have we yet to do? Again, we have NPVs. This will only be the answer as long as our question doesn't fall apart at any point. And it'll only fall apart if we get zeros in denominators. What would make a 0 in that denominator? If x was negative 7. So x equal to negative 7 is 1 NPV. What could potentially make a 0 in that denominator? Well, if x was positive 4. So negative 7, positive 4 are NPVs. When I look at all the steps, it's the same values in my denominator, so I don't need to repeat it. There's my answer. As long as my NPVs, my values of x equal to negative 7 or 4 aren't used. There's adding, subtracting. Now we have solving rational equations. Solving rational equations is going to be a similar process because we're going to use a common denominator, but what's important with solving as opposed to adding, subtracting is we are going to eliminate denominators. And we eliminate denominators by multiplying all the parts or terms of the equation by the common denominator. And they cancel out. So you multiply every term by the common denominator, will eliminate denominators, so you're then just left with an equation to solve. You could have a linear equation where you just have x and constants. That's just algebra. You could get left with a quadratic equation where you have an x squared term. It's going to be more work. That was an entire unit that we did this year. In that case, you're going to have to move all the values to one side and do factoring or the quadratic formula to solve a quadratic equation. So everything builds. Here's your equation. So I want to get rid of denominators, but I need to start this question by factoring. So in this case, I have a trinomial, multiply to negative 2, add to negative 1. That's going to be x minus 2 times x plus 1, because negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1, so there's our factored form. So everything is now factored. In order to eliminate denominators, I need to cancel or multiply, everything by the common denominator. Well, here's an x plus 1, here's an x minus 2, and this term has both of them. So our common denominator is x minus 2 times x plus 1. That's the common denominator for all three of these rationals. So I'm going to show one more time, like I did in the lesson, what happens. I take my first term and I multiply it. Sorry, I just want to use a dot here. It's not an x, that's a times the common denominator. It has to multiply by all three parts. I need to multiply that first 5 over x plus 1 times my common denominator of x minus 2x plus 1. What happens if I write it as a fraction? Again, before multiplying, I cancel things. So the x plus 1 that's already there cancels out. I now need to distribute 5 times x minus 2. Now I have my second portion, which is 1 over x minus 2 times x plus 1. I need to multiply that entire term by my common denominator. But before I can cancel, and that's the whole point, by canceling common factors, we're eliminating denominators. In this case, everything canceled, so I'm left with 1 over 1, and I'm subtracting that. So subtract 1. And the last portion, the other side of my equation was 3 over x minus 2, and if I multiply every term, my last term by the x minus 2x plus 1, well, here we see the x minus 2's cancel, so when I multiply numerator, I distribute the 3, and that will equal 3x plus 3. There's my new equation. Denominators have been eliminated. So I solve. 5x minus 11, because I combine my like terms. Going to move my x over here. 5x subtract the 3x is 2x. Going to move my 11 over here. Negative 11 becomes positive 11 when I move it to the other side. So 3 plus that 11 will equal 14. And x will equal 7. Now, we have to be careful because we always have to verify. And verification of these, remember, depends on your NPVs. What are the NPVs for this question? Well, again, don't want a denominator of 0 there. Don't want a denominator of 0 here, which means neither one of those can be 0. Don't want a denominator of 0 there. And those are where my denominators are. What will make a denominator of 0? Well, if x equaled negative 1. What would make a denominator of 0 here? Well, if x was 2 or negative 1. And the denominator of 0 in the last one, if x was equal to 2. So there's my NPVs, negative 1, 2. That means my x equals to 7 is correct. But we should always verify. Plug that 7 back into the original question, see if it balances. And that's something you can do on your own, but I'll tell you that it does balance. No extraneous solutions. So the last bit that we talked about was we did the word problems with rational equations. Solving is going to be what we just reviewed, solving rational equations. That's what the word problem is going to lead to. But we need the rational equation first, and that's why word problems are tricky. We have to set it up. Well, two particular types of problems you need to be familiar with: distance problems and rate of work problems. Understand how those problems work. There's a video on each of them. Review if you don't understand, but those are the problems you need to be familiar with. There's chapter 6, rational expressions and equations, summarized in 25 minutes or less. Lots to think about. No new skill sets, just a ton of steps with lots of room for error. Practice. Be ready for the assessment. Have a great day. Oh, Wait, I forgot one little bit. Now to review. There's the overview. To review this, you have review pages in the Google Classroom. In the worksheet section, there's the Blackline Masters supplemental pages that are available to you, but also there is a Chapter 6 Rationals review. Those are great review documents. Answers are supplied. The textbook, pages 352, 355, also some great work in there. Don't review the stuff that you know. Look for the things you're struggling with. Give those a try. There you go. 25.50. Less than half an hour to review. Whole bunch of ugliness, but beautiful ugliness. Have a great day. For sure this time.